Okay, so to solve this problem, you recognize that because 3/7 is half of 6/7, this looks like a quadratic. It's a problem that can function just like a quadratic, and we can do that by making a substitution. Before we do that, though, let's add 125 to both sides. And then we can really see that this looks like a quadratic. Okay, because it's got 6/7 and 3/7, so 3/7 times 2 is 6/7, so it's half of that. So you make your substitution, and the substitution is always whatever the middle term is. So if I substitute in for u, I'm going to get negative 126u, right? Because I let w 3/7 equal u plus 125. And then over here, if u equals w to the 3/7, then u squared. And that's what it always should look like. When you make your substitution on these problems, you should make it look exactly like a quadratic. Now you try to factor it. And it can factor because 125, to get 125, we could do a negative 125 and a negative 1. And so that means u can equal 125 and 1. So that means that these are a possible value for u. We got to plug them back into here. So we say w to the 3/7 equals 1. Well, anything to the 3/7 to any power that equals 1 has to be 1. So this tells us that w also has to be 1. And then we have w to the 3/7 equals 125. Well, we want this power to be 1, and so to do that, we have to raise it to the reciprocal power, which would be to the 7/3. So to the 7/3. And so this answer is going to be 125 to the 7/3, which if you do 125 to the 7/3 on a calculator, you get 78,125, which is a solution to this equation. So if you recognize, the reason I did this was because when you multiply those two together, you get 1, and we wanted to find out what does w to the first equal. And then I just typed in 125 raised to the 7/3 power in parentheses, and that gets you your answer. So your two answers are w equals 1, w equals 78,125.